Good morning, everyone. Welcome to today's National Geographic Explorer Classroom Hangout. My name is Joe Grabowski. I will be your host for today, and I'm very excited to be joined by classrooms from around Canada and the United States as we embark on another BGAN Hangout. So if you guys don't know what that is, it's basically a satellite unit the size of a textbook. And the exciting thing about these units is it lets us connect pretty much anywhere on Earth other than the North and South poles. And today we're very fortunate to be joining three National Geographic explorers, Stephanie Grocke, Ross Donihue, and Gabby Salazar. They're on a month-long expedition to Guatemala conducting innovative science on top of an active volcano. So as you can see, they're joining us from pretty high up today. How are you guys doing?
Doing great.
A little cold.
Hey, everybody.
I can imagine. I can see it looks like we got a beautiful clear day, which is phenomenal.
Yeah, we should actually go ahead and show you what's going on behind us because we're afraid the clouds are going to roll in. So if you guys want to see, this is what we're looking down onto and Ross. Researching.
And if we come up, can everyone see that back there? Those are the active lava domes. That's Santiaguito. And then as we pan over, you can see some of the other domes there. So that's what we're viewing today.
All right, and I'm guessing that what we can see above those domes, is that ash?
Those are actually clouds right now that are hovering over the domes. And only one of the domes is active right now. It's called Caliente Dome. But this whole system has been active for over 90 years with continuous explosions happening every couple of hours.
And so we're probably coming up on the explosion.
Yeah, so if anyone sees an explosion behind us, you have to let us know because we can't see it.
All right, and how high up are you guys right now?
Right now we're at 11,995 feet. So we're just at 12,000 feet and looking down. So we're safely sitting on an older volcano called Santa Maria. And Santa Maria exploded in 1902 and had a really huge eruption. And the volcano lost half of its side. So just below us, it is a huge vertical drop where the volcano just blasted itself open. And then what was remaining was some activity down here, which over the last 90 years has formed 4 different domes. And so that's what we can see now. So if you look there, those are some of the older domes, and then this is the more active dome over here. And the active dome is the one that has the most clouds over it right now. And that's because there is some activity ongoing where gases are constantly coming out, and that forms that white stuff along with the clouds.
Well, this is absolutely incredible, guys. We're watching you up on the summit. We can see the clouds moving over top of you. It looks incredibly clear and just crisp. I can imagine it's a little bit chilly. But we'd love to know a little bit about each of you. Can you tell us a little bit about who you are and what you do?
Yeah, so I'll start. So I'm Stephanie. I'm a volcanologist. So I study volcanoes for a living, which is pretty awesome. Some of them are active, like the one we're looking at today, and some of them were active millions of years ago and are no longer active now. But the goal of a volcanologist is really to figure out how volcanoes work. So we think about the magma deep in the earth and then how that magma comes out through volcanoes to produce explosions and lava and just new continents that we're walking on every day. So that's pretty much my goal. And specifically up here, we are using some new technologies to try and actively monitor this volcano. So one thing we don't know is when a volcano will erupt, right? We can't predict when an explosion will occur and when hazards posed to local communities and things. So our ultimate goal as volcanologists is to figure out when volcanoes will erupt and then how they're going to erupt. So that's what we're working on here. So just to show you real quick, what I've set up are some cameras. Can you guys see that? So this is a camera that is pretty new device that is pointed directly at the lava dome that's exploding every once in a while. And I have 3 of these cameras set up all across Santa Maria, all across the volcano, as far as we can go. And they're all pointed on the same volcanic dome. And we're trying to just capture what the dome is doing using time-lapse. So we're taking a photo every 5 seconds for hours at a time. And when we put that all together, we get a movie. And we can start to see how the top of the volcano is moving through time. And that's our goal. So that's what I'm here doing, sort of doing the science side of things. And then I'll pass you over to our 2 storytellers who are linking basically the science that I'm doing with the hazards and the people who live around the volcano.
Great.
Hey everybody, my name's Ross and I'm a cartographer, which means that I make maps. And one of the questions I get all the time is, how do you make a map? And so a map is made up of different layers of information. So things like roads, things like rivers and lakes, even points like cities. And here on this expedition, I'm making maps that tell stories about volcanoes and communities living near these volcanoes. And so Gabby and I are teaming up to be part of the storytelling team. If you come a little closer.
Sure.
Yeah, perfect.
Yeah. So my name is Gabby Salazar and I am a photographer. And so I actually started photography when I was probably around some of your 11 years old. And since that time, I'm 30 now. So that's a long time, 19 years. And since that time, I've been able to go all over the world, mainly photographing wildlife. So volcanoes are kind of a new thing for me. But as a wildlife photographer, a lot of what I do is work with scientists because scientists know everything about the species that I want to photograph. So I might go to Alaska and work with somebody who studies brown bears because they can help me anticipate the movements of the brown bears and the behavior. And Stephanie here can kind of help us, to the best of her ability, at least look at the volcanoes and interpret what we're seeing. And so Ross and I are using photography, videography, and cartography to create an exhibit that's actually going to open here in Guatemala at the end of the month. It'll be all in Spanish, and it'll hopefully communicate a little bit of the science that's going on the volcano to the people living in the towns surrounding the volcano.
And one of the things that maps allow us to do is connect people with places around the world, even if you can't visit them. And so one of my favorite things is to work with scientists to make maps of their data and their research. And so one of the biggest goals is to try to take this really hard to understand research and turn it into meaningful information that anyone can understand. And maps allow us to visualize this information and communicate it to a larger audience. And so between the whole team, we're able to do more than the sum of the parts. So this collaboration is really exciting for all of us. We both haven't done a lot with volcanoes, but we've traveled around the world doing different projects, and Stephanie brings so much knowledge into what's going on behind us.
Let's do a pan.
Yeah, we're just going to show you a little bit more of the landscape real quick.
How's that looking?
Well, guys, once again, this is incredible.
You guys can see back there, there's the tallest volcano in Guatemala. It's right behind me. So let's see if you guys can make that out.
Yeah, the view is absolutely phenomenal. We have a lot of classrooms watching online, and I'm getting a lot of responses from them. Wow, and this is awesome. So they're totally having a blast. We've got a great group of classrooms joining us live. But can you tell us a little bit about what the expedition's been like so far?
Absolutely.
Yeah, so right now we have this kind of bluebird day, which is really lovely. But last night was a little challenging. So one of the challenges is
that's an understatement.
Yeah. You know, one of the challenges is that as photographers and bringing up the equipment, we have to hike it all up on our backs. So it was very heavy, and we had quite a big climb yesterday to actually make it to the summit. And then last night.
So part of that climb too is that we're carrying not only our tents and our sleeping bags and sleeping pads, but we're also carrying all of this heavy equipment like drones and cameras and tripods and all that stuff. So we actually work with a lot of the locals here. So we have a guide who is also essentially a volcanologist at heart. He loves volcanoes, so he's been guiding us. And then we teamed up with some porters who helped bring our stuff up, who are also local guides. And then we also
have another videographer here with us who's helping do extra video to make sure that we capture the whole volcano and all of the different things that we're doing.
And then we also have, since we're in Guatemala and we're carrying a lot of equipment and all this stuff is really expensive, we've also have 2 tourist police with us. And so these 2 guys are amazing. They hike all the way up the volcano with us, and they basically protect us so that nothing gets stolen and we're safe, and that everything just goes smoothly for the time that we're at the summit, which will be likely 2 or 3 nights before we head back down.
And we've been able to hike all together, talking in Spanish and English and sharing stories, and then having meals together has been really, really fun.
Yeah.
So the hike yesterday took us about 6 hours, and you basically climb right up this older volcano, Santa Maria volcano. And that gets us from the base, which is the town where we've been staying in a little hostel when we're not on top of the volcanoes. And then we hike up for 6 hours, and that gets us here to this beautiful view of the active Santiaguito domes below us.
And last night was, I think, notable because right now you can see behind us, but I don't know if you guys can hear it, but it's super windy here. And last night it was really, really windy to the point that we thought our tents were going to blow away. And we were completely in a cloud. So we're so high up that we're essentially constantly covered in clouds in the afternoons and sometimes at night. And so it's just like you can't see more than a few feet in front of you, and you're completely socked in, and there's moisture gathering on everything, all the cameras and our clothes. But luckily we woke up to a nice sunrise.
Yep.
And we kept waking up every 2 hours or so to see if it had cleared. And we could hear that the wind was still going, but we wanted to do some of the photogrammetry at night as well as night photography. And so, we'd look out of our tent and see if it was clear, and maybe the stars would be good, but then you couldn't see down in the lower valley, and the wind would pick up, and then a big cloud would come over. And so it was a lot of tossing and turning last night.
Yeah.
And it's cold. It's cold.
As you can see.
Yeah.
Well, I'm certainly glad. I was going to say, I'm certainly glad everything's worked out for today. I'm sure these clear days are days that you really like to take advantage of because you can really get a lot of work done.
Yeah,
that's
Absolutely.
correct. Yeah. So we have, should we do a pan of the camp?
If we can, maybe in a minute.
Yeah.
Yeah. So what we're sitting on up here, just to give you an idea, are what's called pumice. I don't know if you guys can see this. This is a rock type. And this is all over the ground here, what we're sitting on. And this is pumice, which is basically made up of minerals, glass, and then bubbles. So gases were in here. And so this rock is really, really light. And this is the rock that erupted when the volcano we're sitting on here today exploded in 1902. So we have all this evidence that this explosion happened in the rocks that we as geologists study, which are just under our feet, scattered everywhere up here.
All right. Well, as I mentioned, we have a ton of viewers right now who are watching online as well as our classrooms. So I just want to give a shout out to those viewers. Please send us in a little message via YouTube, the live chat. Let us know who you are, where you're watching from, and you can send in some questions as well. And as well to anybody watching along, if you take some pictures in your classroom, please post them on Twitter with the hashtag Explore Classroom, because we love to see classrooms in action. I was wondering if maybe you guys would like to meet some of the classrooms and take some of their questions.
we'd love to.
All right, well, let's get started. So first, let's head over to Austin, Texas. We have a group of kindergarten through grade 5 students at Laurel Mountain Elementary. Let me turn on their microphone. Hi guys, we'd love to get one of your questions.
Third and fourth grade.
Oh, third and fourth grade? Excellent. Well, let's get a question. We'd love to hear from you.
Come on.
How's it like to be in the next to a volcano?
Why do volcanoes explode?
Why do volcanoes explode? We'll get to yours in a second.
Why do volcanoes explode?
Send that over to the
So we heard one question that was, why do volcanoes explode? So have you guys ever taken like a Coke bottle or something and shaken it all up and then opened up the top and then there was an explosion? Does anybody know? So that's basically the thing that's happening under a volcano. So basically in the earth, there's magma. You guys might have heard of magma. And in the magma, there are gases, but you can't see those gases. They're just dissolved in the liquid. And then eventually the pressure inside the magmatic system gets so high that those gases come out of the liquid and cause the volcano to explode. Same thing that's happening basically in your Coke bottle when you shake it up. So it has to do with gases. That's really what drives the eruption. And then pressure. There's an overpressure and that forces it all out. Does that make sense?
It does, and great question. Thank you so much, boys and girls. We're going to visit each classroom once right now to make sure everybody gets in. So we'll visit our next class, Mr. Richards, grade 6-7s in Amherst View, Ontario, in Canada. Let me turn your mic on. Morning.
Good. Yeah, very good. All right, Keely's got a question for you.
Okay. How long have you guys been doing this type of stuff?
So I've been doing it since I was 11 years old, and my dad was a photographer, and he got me into photography by taking me just out in my backyard in North Carolina where I grew up. And I was so interested in photography that I just kept pursuing it, and I entered photo competitions like Scholastic Art Awards, things like that. And I gradually started publishing in magazines, and then eventually became a National Geographic Explorer, which has been just the most incredible life I could have imagined for myself. But I really think it means that I really think you can do anything you set your mind to if you have a passion for it. And I think that's really played out in my life.
For me, I started making maps when I was in college. That was when I was about 18 or 19 years old. And I really loved going out into the field and using a GPS unit to go collect data and then take that data and turn it into a map that tells a story. And so one of the tools that I've been using is just a phone to collect a lot of data on this trip. So I don't know if you can see this, but that's all data associated with our expedition so far. And there's points and there's lines, and that data can then be used in some graphics for the exhibit or for some scientific research that's going on. And so for the last nearly 10 years, I've been making maps, some in the US, some abroad, like in Chile or on the coast of San Francisco, on the Farallon Islands, all working with scientists to make maps and digital media that tell stories.
Yeah, and I got into, so to become a volcanologist, you have to study geology. So Earth processes and what's going on our planet actually and other planets. So I started doing that maybe in college too, but even before that, I was just really interested in the outdoors and hiking and being outside and traveling and, you know, learning new things and especially surrounding the environment and nature. And so geology was a great career choice. And from there, I just became more and more interested in volcanoes. So the first time I saw an active volcano was in Hawaii. And there, the volcanoes are so neat because you can go right up to them, and they're pretty safe. And they erupt differently than what we're seeing here today. They erupt, as we call it, effusively, so kind of slowly and cascading lava flows. And here, it's a bit more dangerous because they form a big explosion, so you don't want to be too close to it. But regardless, my career track as a volcanologist has really taken me all over and studying all sorts of volcanoes. So yeah, I guess I would say for the past 10 years or so.
All right, another great question. Thank you very much, grade 6, 7s. We are going to jump to our next classroom. Your microphone's on. This is Mrs. Brady's class. They're joining us from Festus. There's a grade 6 students. I believe they're in Missouri. How's everyone doing today? All right, go ahead with the question.
What is the biggest volcano you've ever been to?
Oh, this is fine, yeah. You're asking the right question because actually a lot of my work has been on what we call super volcanoes. So maybe you guys have heard of Yellowstone in Wyoming. So we have a super volcano in the US. We actually have multiple. But these volcanoes are so big that some of the ones I've studied have been in Argentina and Chile and Bolivia, where the central Andes are, that big mountain range. And some of those volcanoes are so big, we didn't even know that they were volcanoes until we had satellites that could view them from space, because these things are 40 kilometers across. I mean, you're in the volcano and you don't even know you're in it. And very different than what we're viewing today, which is much smaller and we can kind of grasp the scale. Huge volcanoes, they produce eruptions that, you know, can cause the global climate change to actually change the global climate. And they can also produce ash and hazards that travel hundreds of kilometers. And so if you've heard of the Mount St. Helens eruption, maybe in the US in 1980, these are eruptions, what I'm talking about, that are 1,000 times as large as that eruption. So huge. There are some huge volcanoes out there.
All right. I want to give a shout out to some of the groups who are watching us online. There's classes in Oregon, there's classes in Maryland, we've got classes in other parts of Canada. So thank you for sending in your questions, and let's get a couple of those questions in right now. So let's combine a couple. So one class is wondering, in Oregon, they're wondering about the most common minerals in igneous rock. And then another class is wondering about warning signs. Mrs. McLaughlin's class, warning signs before a volcano erupts.
Great. So the most common mineral in the continental crust, so the crust that we're standing on, is feldspar. So maybe you guys have heard of that. There's a bunch of different kinds of feldspar, but it truly is all over the place. And it's in these, the pumice that we have up here too. There's feldspar in this as well. It's a plagioclase feldspar. So that's a great question. And it's kind of hard to see, but even in these pumices that we have up here, these rocks, we can identify some minerals in here. So they're pretty big crystals that you can just see with your naked eye. You don't need a hand lens or anything. And then some of the hazards. So there's widespread hazards from volcanoes. One of the big things to just sort of think about are that this volcano behind us, for example, has been erupting for over 90 years. So that means the hazards associated with this volcano have also been, you know, potentially causing risks and hazards to the nearby communities for that long as well. So decades, you know, almost a century. And in the case of this volcano back here, some of the biggest hazards are lahars. So you might have heard of these. They're volcanic mud flows. So when the earth gets really wet, it can actually cause almost like a wet landslide. And those things can be really dangerous for the communities around here. And another hazard is when these explosions occur, they produce a lot of ash. And the ash is made up of these little glass shards. And so the ash can be really hazardous to infrastructure, to your own health, to your livestock. And then another hazard here from this volcano specifically are pyroclastic flows. So imagine these really hot flows of ash and gas, and they just come streaming down the volcano and take out basically anything in their path. So these are some of the things we're trying to better understand when they might occur, to try and predict these hazards so that we can keep nearby communities safer from volcanoes.
All right, great questions, and please keep them coming in online. Let's meet our next group. So this time we're going to go to Markham, Ontario in Canada. We've got a grade 5-6 classroom joining us from Mount Joy Public School. Let me turn your microphone on. How's everyone doing this morning?
How does a volcano deactivate?
Great question. So how does the volcano basically stop erupting? That's a really good question that we scientists are working on right now, as a matter of fact. So one way is that when the magma is in the earth, it's really hot. And that's what allows it to sort of act like a fluid, so it can actually flow more or less. And that, when it gets buoyant, so when it's allowed to sort of come up through the earth, it can erupt through the surface. But sometimes if it's been a long enough time, that magma can cool and it can solidify. And when it solidifies and it hardens again, it loses its fluidity and it can no longer erupt. And then it just becomes this solid body of rock in the earth. And another thing to think about is where the magma is coming from, really, really deep within the earth. And sometimes there's magma coming up continuously and the volcano gets continuously resupplied. But other times that supply stops for multiple reasons. But under this volcano, maybe there wouldn't be a supply anymore. And so the magma might get diverted and go somewhere else. And so a great example of that is what we're looking at right here. So if you see, you might be able to make out 4 domes down there. Can anybody see that there's a line of domes? So what's interesting to your question is that dome all the way over there was active first. And then that dome became active and the first one shut off. And then that dome became active and the 2 before shut off. And now that one's active. So basically the magma is moving in the earth and coming up at different places. And then how we see that on the surface is through 4 different domes. Does that make sense?
All right, that was a great description. Thank you very much. Let's meet our next group. So this time we're going to jump over to Virginia Beach in Virginia at Green Run High School at their iLab with some grade 9 students. Let me turn your microphone on. How are we doing in Virginia today? Excellent. Well, we'd love a question if you got one.
All right. How does a volcano become a volcano?
Oh, I think the best way to answer that question is to think about where volcanoes occur on Earth. So have you guys heard of plate tectonics and plate boundaries? So the Earth is made up of all these different plates, and they're basically floating on the top of the Earth. And in our case, not right now, but in North America, we're living on top of the North American plate. And sometimes when 2 plates hit each other, they converge, especially say on the west coast of the US, like those of you in Oregon and California and Washington and northwestern Canada. The North American plate is colliding with the Pacific plate. And when that happens, the 2 plates hit each other, they don't know what to do. The oceanic plate, or the Pacific plate in this case, is a lot denser. So it ends up going under the North American plate, and this is what's called a subduction zone. And this is happening at various plate boundaries around the world. So the plate boundary that we're sitting on right here in Guatemala is very similar to the one that you guys are sitting on in Oregon and the west coast of the US. And that subduction zone setting basically allows magmas to be generated deep within the earth. We're talking like 100 kilometers down, and it generates these magmas, and then the magmas can ascend through the earth and then erupt through volcanoes. And if you think of how the subduction zone travels from Canada, across North America, down Central America, all the way down into South America, that whole thing is a subduction zone. And that's why we get the line of volcanoes that we get streaming down from Canada. We get Mount St. Helens, Rainier, Shasta, Lassen, all those volcanoes in the US, all the way down to these volcanoes where we're sitting in Guatemala. And then it continues even farther down to South America. So that's an example. That's one way that we get volcanoes, is through this subduction zone process. And that happens to be the one that affects North America and Guatemala.
All right, so I've got a question coming in from a group in California, and they're wondering two things. How are you going to share the story of your expedition when you get back? And then are you sharing your results with the local communities?
Great questions.
Yeah.
We'll give Stephanie a little break.
So one of the first ways that we're going to share our expedition is with a photo exhibition that will open here and the end of the month in Guatemala. So we're working really hard. As soon as we get down from the summit tomorrow, we'll be actually producing these maps, infographics, editing our photos, getting them printed, and actually opening that exhibit in partnership with some organizations here. And that'll all be in Spanish. And that exhibit will live here in Guatemala and hopefully travel throughout the country to be able to reach different communities.
And when we told people we wanted to make this exhibit in country at the end of the expedition, they kind of looked at us like we were crazy. But it was really important to us to, not just fly in and fly out, but also bridge this gap between scientists and communities using art, like photography and cartography.
Yeah, and one of the things that you'll find if you get into science more and more is that when you publish scientific papers, a lot of times those go into these journals that only other scientists read. So you might publish on beetles, the Coleopterus, and only other Coleopterists would probably read your beetle papers, right? But here, what we wanted to do is use existing science that's in these journals that people don't have access to and try to translate it into a way that's understandable and accessible for people. And so we'll be using that in the exhibit, but we also hope to put together some media packages that hopefully National Geographic can use in some way, or other media outlets can use in classrooms to talk about the fact that volcanoes are, well, I think this is cool, like volcanoes aren't just these isolated things in the middle of an ocean. They are actually these systems where there are people living all around them. And so we really wanted to communicate that through this work as well.
Yeah, and they aren't just this prehistoric thing that happened a long time ago. They're erupting every day. We've watched an eruption earlier this morning, and that was a really exciting event. And it was just like, oh my gosh, this is what it's all about. And to be able to communicate that to a wider audience is really exciting. So we'll use social media, as well as we want to connect with classrooms and teachers through tools like this to be able to provide resources for engaging with these, pretty intense scientific concepts, but putting them in context.
And I think one of the cool things about what we get to do, and the challenge, is that, we get to work with Stephanie, who gets to tell us, here's something that's important about volcanoes. And then we get to brainstorm and think about, how do we communicate that in a photo or in a map? So for instance, one image that will be in the exhibit, you can't see it right now, but there are towns and cities all around this active lava dome. And at night, in the middle of the night when we get up, the whole landscape is just dotted with lights. And so we're using night photography to be able to show that the volcano is surrounded by all of these people. And so those are the kind of things that we get to do as kind of creative professionals or storytellers.
And also bringing people into, what is volcanology? Like, what are the tools that people use? So Stephanie's got a whole, really innovative technology that she's using, and being able to, communicate that to a larger audience is really exciting for us.
Absolutely.
Awesome. Thanks so much for the questions. And guys, thanks so much for your answers. I think, you bring up such a good point that so many people live around volcanoes, and it is so important that we try to learn a little bit more, because we really can't predict when they are going to erupt. So I think the work you're doing on this expedition is is awesome, and I can't wait to see what comes out of it. And I know the classrooms are looking forward to seeing some more pictures as well. So let's meet our last group who are joining us on camera. So this is Mrs. Moore's class, grade 5s in Newmarket in the United States. And Mrs. Moore, I might need you just to turn your microphone on for me because you're using 2 computers today. It's going to be tricky to hear just because we're getting the feedback from the 2 computers. But let me just turn it on and see if you can get your question in quick.
Jax, come here. Sorry, he's coming. Can you hear me?
Here.
Yeah, we've got you.
Hello.
You gotta talk loud.
Is there any wildlife, and if so, what kind?
In the area that they're studying.
Great question. As we hiked up yesterday, you know, Gabby and I do a lot of photography and videography, and are always drawn, you know, the flora and fauna that we find, so plants and animals. We were able to see a bunch of hummingbirds as we were coming up, but some insects. And one of the big surprises, you want to tell them?
Yeah, we saw a fox. It was so cool. And it was just in the mist, and this beautiful kind of like red and black mottled fox just kind of emerged from the mist and the clouds and looked at us for a few minutes. We didn't get our cameras out in time, but it was just, you know, sometimes it's just amazing to have the experience.
And that's fine. And you don't see mammals on top of volcanoes that often, so that was really exciting.
Yeah, absolutely. And there's also some really cool lizards up here.
And birds.
Yeah, it's wine-throated hummingbird. If you guys want to look that one up in your classrooms later, that's one of my favorites. And it's up here. And pink-headed warbler, another kind of endemic that's just special to these mountains. So you can Google those. You can see just how special the wildlife is. Great question.
Thank you.
All right. Well, again, the overwhelming thing we're getting online from classrooms is incredible, and what a view of the horizon. So this is pretty great that we're able to do this, and that technology can allow us to connect from somewhere so isolated from, say, the internet or cell phone signals. So that's pretty cool. And the domes look phenomenal. We can see each individual dome. Yeah. So maybe a neat question to end off on that just came in.
How fast
Yeah, we can see the cloud actually blowing right over the summit. That's pretty cool.
Yeah.
So I think a neat question to end off on just came in from, let's see, Laurel Springs School, and they're wondering about volcanoes affecting global warming.
Yeah, so they're certainly not the primary, you know, they're not really influencing global warming to the degree that some might think. Their contribution is very, very, very small. So they're not having a large contribution to global warming really whatsoever. In fact, oftentimes when somebody asked a question about some of the really large volcanoes that I've studied or that I know of, and actually their effect is global cooling. So, and the scale, the timelines that we're talking about in terms of volcanoes are very, very short. So if a volcano can erupt enough gas that it gets really high beyond the atmosphere into the stratosphere, some of that material can get transferred around the entire hemisphere, and the effect of that is actually to cool the global climate. But again, the effect might only last 1 to 2 years. And when we're thinking about global climate change or heating, that's on a much longer time scale. So it's a great question, and something that we as volcanologists definitely want to clarify. So it's an excellent question.
Hey, Joe, would you guys like to see our camp?
Absolutely.
Before we go?
Sure.
Should we try it? We don't, I'm just going to stand it up. Yeah?
We'll see if we
can get the connection. All right, it's going to be a little rocky.
That's okay.
All right, here's our camp up here, if you can see. So that's where we're staying. Oh, it's windy. And there we are right there. And here's the view in the other direction. So it's pretty incredible.
It looks incredible.
Back down here so we can save.
It's pretty windy.
Yeah, it's pretty windy, so we're trying not to blow off the side here.
Yeah, I can definitely
So
see just,
there we go.
I can see from where you move from the sheltered spot into the wind that you guys really are putting up with a lot of wind up there.
Yeah, so there's another view into those active domes. And you can sort of make out the top of that one. That's the active one right there. So fortunately we haven't seen an explosion right within this hour, but I'm sure we'll see a few more today.
All right. Well, Stephanie, Gabby, Ross, thank you so much for an incredible experience and taking us with you. I know the classrooms have had an absolute blast. And yeah, we can't wait to see what comes out of the journey. And I guess you've got one more night on the summit?
Yep, at least one more night. Yep.
Thanks so much for tuning in.
All right. Well, we're incredibly jealous. I know there's a lot of students who'd love to join you right now, but stay warm and safe travels on the rest of your journey.
Thank you, guys.
Thank you. Bye. Thanks.
So I'm just going to turn on the classroom microphones really quick so they can say goodbye and thank you. Let's go, everybody, nice and loud. Goodbye and thank you. All right. Thanks again for joining us on Explorer Classroom. We're going to sign off for today and let Gabby, Ross, and Stephanie get back to work. So thanks again and enjoy the rest of your day.
Bye.
Thanks. Bye.
Bye.